Okay, right, in this video I'm going to talk you through some of the challenge questions that you have been set for the week. So all of these questions are ex-SAPS questions and they are higher level questions. So they are trickier, but I'm hoping that with this video and having a little go at home yourself, that you should be able to find them not too bad. I will say as well that some of these questions have got things we haven't gone through yet, so I'll try and give you some pointers as we go, so that hopefully you can sort of go off and do it independently. So the first question we're going to do is question number 1. So you've got a copy of this as well, hopefully in front of you. And this question, before I even read it, I'm going to tell you that this question involves multiplying fractions, which we haven't gone over yet, but some of you will know how to multiply fractions from last year. Okay, so if you know how to multiply fractions, I would pause, go off and try and work this question out. But if you don't know, that is fine, you can carry on listening. So the question is saying to us that the length of a day on Earth is 24 hours. The length of a day on Mercury is 58 2/3 times the length of a day on Earth. What is the length of a day on Mercury in hours? So there's lots of information there, lots of information that's quite useful for me. So you can do working out on the sheet if you'd like to. I'm going to use my whiteboard. But I'm just going to sort of jot down on my whiteboard some of the important information on here. So I'm just going to sort of do it sort of in a bit like note sort of form. So I'm going to say Earth, so that's 24 hours. And then Mercury, so that is 58 2/3 times the length on a day on Earth. Times on Earth, I'm going to write. And we're trying to find out the length of a day on Mercury in hours. So that's what we want to know. We want to know in hours. So I'm just popping this information down for myself. So I'm just going to pop my sheet away for a minute. So we've got a fraction over here right now, which we're going to have to do some multiplying with. And the question said about multiplying. So it's this many times. So the first thing we're going to do to make our life a lot easier is convert this into a improper fraction. And that will really, really help us. So what I'm going to do is, I think I'll do it here. So I need to convert this into an improper fraction. So firstly, I need to do 3 times 58. Now, some of you will be able to multiply this in your heads. I'm going to do some calculations down here. So 8 times 3, well, that's 24. And then 5 times 3 is 15. Add 2 gives me 17. Then I have to add my numerator. So that would end up giving me 176 over 3. Okay. So I think I might just section off my working out over here. So we've now got 176 times 3, over 3, sorry. And we've got to times that by the number of hours on Earth, because it's 58 2/3 times the 24. So that's how many times more it is. So a day on Earth is just 24 hours. But a day on Mercury is this many times more. So we're going to have to end up multiplying this by 24. Now, those of you who know how to multiply fractions might know what to do at this point. So if I just pop over here. So with regular sort of fractions, if you were to say have something simple, like 2/3 multiplied by, let's go for 2/5. A simple calculation like this, you quite literally multiply your numerators, you'd get 4, then you'd multiply your denominators, and you would get 15. And obviously if you can simplify, you simplify. And that is as simple as multiplying fractions is, which we'll be coming to next week. When you have a whole number over here, obviously you can't, it's not as straightforward, but what you can do is you can, whenever there's a whole number, let's say for example it was, again we'll do 2 and a fifth times by, let's just say it was 2. What you can do is you can just put the 2, the whole number of 2, over the value of 1, because it hasn't affected the value of the fraction at all. The fraction is still 2, but you're just putting it over the value of 1. And then you do the exact same. So you multiply 2 by 2, which gives you 4. Then you multiply 5 by 1, which would give me 5. So, with that in mind, I'm sort of doing that for my question. So I'm going to have to multiply 176 by 24, and then obviously we're going to have to multiply 3 by 1, which we know is going to leave us with 3. So I leave my denominator there. So I'll do my calculation over here. So I'm going to have to do column method for this. So 6 times 4 gives us 24. Pop that down here. I'm going to run out of room, I think, by working out. So pop the 2 there. 7 times 4 is 28. Add 2 is 30. And then 4 times 1 is 4. Add 3 gives me 7. Now I've got to go on to my second digit. So I'm going on to my 2 now. So we'll pop the placeholder in. So 2 times 6 is 12. 2 times 7 is 14. Add 1 is 15. And then 2 times 1 is 2 plus 1 gives me 3. So I've now got 3,520. And that is going to go over... no, what have I forgotten to do? Add it before I get too carried away. So add these together very, very quickly. So that gives me 4, that gives me 2, 7 plus 5 gives me 7, 8, 9, 10 and 12, and then 3 plus 1 is 4. Right, that looks a lot better now. So that is my answer, 4,224, like so. But as we know, when it comes to an improper fraction, we now need to make this into a mixed number now. So we need to go from improper to mixed. So this is our division sum essentially. So that's what the line represents in a fraction. So we need a little bit more working out space, which I'm running out of. So I'll rub this out, I'll rub my calculation out over here. So now I'm gonna have to do a bit of division. So we're dividing it obviously by 3. So 4, 2, 2, 4. And then we do our division. So 3 into 4 goes 1 time with 1 left over. 3 and 12, that goes 4 times with nothing left over. 3 and 2, well that doesn't go, so I'll carry my 2 over. And then 3 into 24 would go 8 times with nothing left over. So I'm actually going to end up with a final answer being, so I'm going to write A over here, so A equals 1,408 hours. And that would be the final answer to this problem. So you might want to pause, go back and watch this again, but this is the method of how you'd work out question number 1. So we're now going to do the second question for today. So we will grab our sheet again and have a little look. So we've got this. So then we've got a little diagram here. Note it says it's not drawn to scale. So this is a diagram of a vegetable garden, and it shows the fractions of the garden planted with potatoes and cabbages, which we can see here. The remaining area is planted with carrots, what fraction of the garden is planted with carrots? So it's this area here we are looking to find out. So the question probably looks a lot more complicated than what it actually is, but if we look at the area as a whole here, it's a rectangle, and that is a whole area. That's a whole area of space. It's like the same as like a whole number, I suppose. So we're sort of trying to say to ourselves, well, 2/3 plus 1/4 plus what would give me the whole area of my vegetable patch. So if I write VG here for vegetable patch, instead of me writing vegetable patch out. So this plus this would give me the whole area. And the whole area is actually going to be 1, because that's one area. Okay? So when we look at it like that, all we're actually doing is an addition question. So what we're going to do, just like we've been doing the last few weeks in school, we're going to add these two fractions together, see what we're left with, and then hopefully we should be able to work out what we have to do then to make 1. So we've got two different denominators here. We're going to have to make them the same. I know that 3 times 4 is 12, and that's going to be my common denominator. 3 times 4 is 12, 2 times 4 is 8, 4 times 3 is 12, 1 times 3 is 3. If I add them together, so 8 plus 3 gives me 11 over 12. And then actually, to make 1 whole now, all I actually have to do is add 1. That would give me 1 whole. So my final answer for this question is actually going to be 1/12. And if you wanted to go back and check, if you were to add 2/3, 1/4 and 1/12, you would end up with 1, which is your vegetable garden.